Okay. I'm happy to be here. Thanks for staying. I'm hoping to kind of give you some good insights on sort of the experiences we've been having at Cisco and working with some of our business units and moving towards this cloud native journey. And I spent a few minutes at the end kind of going through that case study because it is an interesting case study. I think it's important whenever you're kind of in the beginning of a new technology and at a conference talking about technology, you sort of try to think about how you got to this point, what are some of the lessons you've learned along this path. And it really is a journey, right? There's not an easy way to just kind of go from where you're at to the next generation of technology ever, right? And so how do we sort of look at this as an evolutionary path, not a greenfield, stop everything you're doing and start from a different model path. And so there's a few key concepts I want to kind of talk about at the beginning of the talk. I'll go through most of these quickly because you are here because you understand them and you've been hearing about them all day. And so I don't want to spend a whole lot of time on these key concepts, but I just want to make sure that you understand them in terms of the case study. And now I'll talk a little bit about this open source container project that Cisco's been working on called Manti. We built a nice community around this. We also look at it from a developer experience and have something called SHIP that we'll talk a little bit about and what are the benefits of these open source initiatives. And then I'll talk about a case study with the small little business within Cisco called Collaboration and one of our small products, Webex, that I'm sure you've all used multiple times, and kind of go through how Webex is using cloud native and some of the concepts here to kind of evolve their technology. And so I think, like I said, I'll go through most of these quickly, but the whole concept of, moving more towards, the pets versus cows sort of mentality. I do like to kind of point out on the slide, though, that while you maybe don't care as much about your cows as you do your pets, you still take care of them and feed them and put them in fences, right? We don't let them just kind of run around and just do what they want to do, right? And so the fact that it's a cow doesn't mean you don't care about it. It just means that there's lots of cows and there's ways to replace cows. You don't have to depend on a single cow. At the same time that this kind of concept is moving forward, you have this whole this term that I hate from Gartner called bimodal IT, right? Where you have like mode 1 and mode 2 type of transformations happening. And it's really more about moving from very fixed, very static sort of agile, waterfall type of business processes to more application-driven, dynamic, distributed, moving more to agile type of development is really what the key of this whole mode 1 versus mode 2 is. The other interesting concept to talk a little bit about is containers and hypervisors. And so I always I was back in the early cloud days, and I always kept telling people that virtualization does not equal cloud, right? Virtualization might be a technology that some infrastructure providers are using to help orchestrate and manage resources within their infrastructure, but it doesn't make it a cloud. And so when you kind of look at hypervisors and containers, there's type 1, which is sort of the native type of hypervisors, and you have your type 2 hosted hypervisors. And in general, most of these, any sort of hypervisor you look at is going to fit into either bare metal, you're running straight on the hardware, or they're going to sit on top of a host OS. And so regardless of what type of technology, that's the sort of way hypervisors work, right? In terms of containers, it's on top of all of that, right? Doesn't matter if you have virtualization or not, right? Containers are a completely different set of capabilities that allow you to sort of segregate your different Linux kernel space into components and make use of that space through an API. And so that's really kind of a key concept, is to not confuse, is it containers or hypervisors? It's not an either or type of scenario, right? You don't have to have hypervisors. You never had to have hypervisors, right? You don't have to have, Linux, right? But a lot of people choose to have Linux. And so it's really a choice of what you have and want to deploy, and then how you want to leverage that deployment is really the key. The other thing is that we're making this big shift in the industry today from a very well-defined, well-known set of architecture patterns, where you have like a DMZ with a very clear set of demarcation rules and access lists and security controls around it, where you put your presentation logic, and then you go through another firewall and set of intrusion detection systems and get into the next level of tiers of logical components, which then have another set of common firewall controls that secure that persistent and that database components, right? And so you have a very clear set of capabilities into this microservices world that is really API, as you've heard today, very API-driven, very services-oriented in nature, consuming and managing through either REST APIs or through direct sort of service calls. And so when you move to this new model, the complexity of all that infrastructure gets moved into the network. And so the network is now really important, and I'm not saying that as a Cisco company, right, but just in general, looking at this in the industry, right, the network becomes very important because it's the bottleneck and the control point and all the different services that need to connect and communicate with each other are all going through the network now, and versus having tiers and layers of complexity off to the side that you could have someone else manage. Now, as an app developer, you have to worry about how your network is performing. You have to understand if you need a better network. You have to understand what issues are happening in the network. Whereas before, you had a whole group of individuals off to the side that you could call up and say, hey, I have latency, or I'm having issues with my performance of my app. Can you check into it? That's no longer the case. Now that's your job to figure out why your network is not performing the way you'd expect it to. So, the other key concept, and you heard this in the previous panel, right, is this definition of cloud native. And so, thanks to some of the work that's being done in the CNCF, we've defined it as containers or containerization, distributed orchestration and management, and then microservices architecture. And what do I mean by microservices architecture? To me, that's sort of if I were to say what's the key objective of understanding cloud native, it's really around this term microservices architecture. And I kind of broke it down into these 4 areas, and there's not meant to be like any sort of relationship direction. Like it's not like you have to follow the graph around from the right to the left or the left to the right. But it also isn't meant to represent that you can go like any direction you want either. It's just sort of a set of capabilities that make up an architecture. And so you have application composition, which is probably at the highest layer in terms of like a layered idea, right? And this is where you come up with like, how does my application decompose into a set of microservices, right? It has to do with how do I like understand the different aspects of my application so that I'm not making too many microservices and making it too complex. What are the sort of requirements I have in the API layer to allow these microservices to be connected? What dependencies or loosely coupled dependencies do I have existing? So that's sort of where that layer takes care of that. To the right of that, you have this policy and event framework. And this is where some of the, I think, requirements of an enterprise and more stability around deployment architectures and software come into play. As you develop your application, you always have thought in the past about policies and events and how do you get data, what do you do with this data that you're collecting, how do you manage this data, how do you use this data to help you give insights into what you should be doing in the business to make your application better, right? And so I think in general, that's sort of, to me, part of the cloud native definition because that doesn't exist in a lot of the technologies that are cloud native technologies. So a lot of this is being developed today by developers because it doesn't exist. And so they have to kind of create all this, what's my identity management capabilities, right? How do I plug into my LDAP? How do I let my users plug into and authenticate into my services? And so figuring out some of those policies are really important. That also kind of bleeds into the thing across from it, which is this common control and operations capability, right? So how do I manage this in my existing operations consoles? How do I understand what a failure means and what failed and how do I fix that failure? And then also, how do I sort of create compliance and like network security controls and things like that that are needed to isolate data that is proprietary or has information that's critical? And I think the last piece is kind of an important part of why I did separate the delivery from the composition is that the application composition and some of those services needed around application composition don't have to necessarily depend on how you deliver that application. And so you can kind of abstract away how you write and design your application from how you're going to deploy it. And that's sort of the key of, I think, this infrastructure substrate that we want to create in the CNCF that allows you to not have to focus on all the different interfaces and APIs of the underlying infrastructure, just to have those as sort of supported environments, like you saw in earlier talks, supporting these different components of the infrastructures that are out there, not creating yet another infrastructure, because you don't necessarily have to do that. You can run on bare metal, so that gives you that capability, but kind of separating the deployment from the rest of the composition allows you to have that freedom to write your code and optimize your code irregardless of how you're deploying it. And if the business decides tomorrow to change who they partner with and who they buy services from, you don't have to refactor your code because you wrote it to only work on this one cloud provider or this one set of services. So those are like the key concepts. I'll kind of go through this quickly, kind of tell you a little bit about what Mantle is and why we did Mantle. And so you think about sort of the last decade or so of, kind of the way data center networks and services and compute and storage have all evolved. You kind of have this picture on the left. This is how we kind of look at the world today. So you have your basic infrastructure components. You have your hypervisor, if you have one, with the virtual vApps and vNetwork and vOperating system on top of that. And then you sort of have this orchestration and management piece. It's kind of a static orchestration management piece. You have your configuration management components that are kind of tied back to your CMDB type of model. And you have something called workloads, which are kind of like patterns or sets of metadata around your application. And this is very quickly moving to what we're kind of calling this container stack. And the container stack has a lot of similarities to the existing stack, which you'd expect because it's just kind of an evolution, as we've been talking about all day. But now you're looking at things that are more distributed and more dynamic in nature. So now you have cluster managers, and the workflow component is now more of managing of different workflows and different interfaces that you have to manage workflows with. And then you have this new layer that's, I think, really important that we just talked about with microservices. That's API and this application composition and delivery components are sort of off at the top of the stack in how you define that application, irregardless of what those underlying components are. You don't have to really worry about what sort of components are underneath that stack. As long as you know you have these components available to your service, you can then call out to a service, and that service will be available for you to call out to. And so when I think about Mantle, right, I kind of took that picture and showed exactly what we've implemented with Mantle from an open source standpoint. We kind of started with sort of the top layer with the proxy and load balancing, so making sure that you have a set of abstracted network interfaces. You have the ability to do some very basic load balancing and service discovery components. We then tie in application orchestration that can be done in a couple of different ways today. Tie that down into resource scheduling, because at the end of the day, from an IT operations standpoint, when you're looking at what their job is, they're trying to make sure that they have resources that they can optimize the use of those resources. And so the resource scheduling becomes really important at the IT layer, maybe not at the application development level, but at the IT admin layer. They want to make sure that they optimize the resources. And then you kind of get into the container runtime pieces and the resource management of the underlying underlay at that point, and some of the underlying physical components and provisioning to those components is also important at this layer. And one of the things we've kind of discovered with Mantle is that if your application orchestration works well at, like with the Kubernetes, you should probably leverage Kubernetes as well at that underlying provisioning layer, because it's going to work to schedule work as well down there as it does at the higher levels, right? And so that's one of the things we've learned with Mantle. If you want to learn more about Mantle, feel free to go out to mantle.io. It's an open source project and pretty good sized community today, and we'd love to have your input on it. Because of some of the work at CNCF, we've added things like Kubernetes and Prometheus to the project, and so as we keep adding more and more projects to CNCF, we'll keep adding those projects to Mantle. It's an extensible platform, so it's not meant to be like a one-size-fits-all type of solution. If you're curious about what it really is, I thought I'd put a slide in just for those of you that want to know the details. And so these are the tools that we have in place today and the projects that we're supporting. These are all open source projects. And so it kind of gives you a good idea of what we have. And yes, we support both Kubernetes and Mesos because there are different use cases for Kubernetes and Mesos. And when I get to my customer story, you'll see why, because they're doing data analytics and they needed Mesos for the data pieces they were working on. In terms of a high-level architecture overview, this is sort of how it connects together and how we support multiple services from both Mesos and Kubernetes. So we're not We're not trying to embed one in the other or trying to hide one or the other. We basically expose both of them, and you can leverage either or both. We don't really care. And then we abstract the underlying infrastructure using Terraform. So as long as you know how to leverage and create configurations in Terraform, you can pretty much talk to anything that Terraform supports as a packaging standpoint. Then on top of that, what we looked at was, it's great to have sort of the technology pieces and help the IT admins and the network admins understand what's happening under the covers. But that really wasn't enough, in my view. I kind of felt like the developers are the ones that have a lot of complexity in this new model. And kind of starting back with cloud, we've made the developers' lives a lot more complicated. And so what I wanted to kind of do was look at how do you separate that developer experience from that underlying set of tooling and componentry needed to help deliver the service. And so that's when we worked on an open source project called Shipped. If you'd like to know more about Shipped, feel free to go to ciscoship.io and use it. It's available for your use, and it's completely free, no cost to use it. Running on Google Cloud. So, and then the last thing is to kind of show where Shipped fits into this overall picture. It's kind of at that top there with the application definition and developer experience piece that I talked about earlier. And so when you kind of look at Shipped and Mantle, Shipped leverages Mantle under the covers, but it also works with OpenShift and with Cloud Foundry, so it doesn't have to be Mantle. And that's kind of, I think, the key message is it kind of lets your developers develop how they want to develop, and then you can manage and support how they deploy it under the covers. That's sort of where we're at today with Mantle. Is sort of this big picture that I want to kind of show with the vision that we have today. And sort of change over time, obviously, but it's kind of a busy picture, but the easiest way to think about it is on the left-hand side, you have the different user personas that we're trying to address. Again, kind of thinking about this more holistically as an open source project, there's a lot of different users and different use cases that we wanted to try to address. The middle part there talks about like management and compliance and network and security. So there's different sort of policies that are in the enterprise space today and in the service provider space today. And they kind of have this set of, if you will, sort of rules and compliance and controls around this set of use cases. And so trying to map those use cases into something that works in cloud native in the exact same way that works in the non-cloud native world is great and important to them, right? I haven't had the benefit of working with a company that can just do a whole greenfield deployment. They always have existing infrastructure that they have to work with and deploy into. And so it's always trying to like help them figure out how to bridge between the old and the new that's important. And so in that center layer where you see those policies, that's where a lot of the networking innovations that we're doing are coming out, right? And so we from a policy standpoint, we have something called Conti, which is an open source project with net plugin and storage plugin that we call Vol plugin. And it allows you to sort of take the existing policies you've defined in your network, a physical network without containers, and map those policies to your container network. And so you can define your policy once, and then that policy will follow your services, whether they're containerized or not containerized, across your different deployment locations. And then what's really interesting is performance is important to a lot of our customers. And so they asked us, how are you going to make container networking higher performing? And so we kind of looked at the container networking space. We looked at the Linux kernel and what was being done in the Linux kernel networking and in other projects. And we said, look, they're doing a lot of control plane stuff, a lot of underlay and overlay and BGP routing stuff, but they're not really doing anything to make it fast and to user plane, right? And so we took our VPP project and open source that is something called FIDO, FDIO. We have a demo of that out in our booth if you want to see that at the next break. Love to kind of show you and talk to you about where we're going with higher performing networking in the container space. And again, FIDO, along with everything we try to do at Cisco to be more part of a community, works with Calico. We have that demoing in the booth. It works with Contive. It works with, it will work with Weave. I think it's something we have on our roadmap to do. So we're not trying to create the only network capabilities, right? We're just trying to make the network a lot better. And from a network admin standpoint, we want to work with you and help direct your actions into the networking space. if you're an admin, or if you're a developer, we know you don't care about the network. And so we're not going to ask you to do anything or to find anything on the network. You can trust Cisco to know what you want to do in the network, we'll make it happen, right? So you just write your code, publish it, we'll make the network perform better and faster and more secure for you, because I haven't met a developer yet that says, Ken, I don't want you to make my network faster. I don't want you to make my network more secure. Let my application get hacked, please, right? I just haven't met one yet. Maybe there's one out here. I doubt it, right? If I can make it much better, you're going to be happy. You're not going to have to pay for it because it's open source, right? That's the key. And so, some of the key benefits, I'll go through these quickly because I want to get to the use case. And so hybrid cloud deployments is one of the key things that we wanted to solve with this open source project, because there's a bunch of choices out there, and a lot of companies are already using Amazon, a lot of companies are using Google. A lot of companies are deploying their own, whether they're using VMware, they're using OpenStack, they have their own private clouds. And so kind of supporting this hybrid mode and allowing traffic to not have to flow through control points. And so this isn't like you notice these lines don't go from Amazon back to your data center, then to Google, right? They can go directly from Amazon to Google, right? It goes directly from Google to Amazon. We're not trying to route or reflect the routing to make it happen through a certain method that you have to follow, right? We're basically letting the applications get deployed where they make sense to be deployed, and then route where they make sense to be routed to without any sort of limitations. We also have something we're calling network autopilot, which is sort of this ability to create these microservice policies that tie back to your physical network, and we can kind of monitor those policies, and we report back to you in terms of what is happening within the underlying network that your applications are running on, and we'll let you create actions. And with those actions, you can do things like scale up. You can do things like, isolate this VM because it's been, hacked. You can do, different actions and different policies based on what you're trying to accomplish with your network intent. And then the last thing is this idea of cross-orchestration balancing, right? And so we've been able to kind of look at, abstracting the orchestration completely from the application developer. So you can just write your application saying, hey, I need a resource. If you don't really care what the resource is, we can give you options of either one and then move different slaves around as needed. And so that's sort of the three main use cases we've been working with a lot of our customers, including Webex. And so what Webex is trying to do is, just like a lot of enterprise applications, they wrote their application to be very monolithic when they first wrote Webex. And they've done some things to kind of pull out pieces of Webex over time, like Cisco Spark, to give you sort of more of a kind of a very friendly cloud interface that works in the web environment's a lot easier. But they wanted to sort of start taking the control plane and isolating the control plane into different microservices and making it more of a software architecture, because that helps them deploy the controllers a lot faster and easier if they don't have to actually ship hardware to some site and have to set it up. And then they can also do things like auto configuration of those control plane servers. Once the services get spun up, they can actually remote log in and configure them and manage them for our customers. And so there are a couple of drivers for why they wanted to do something more cloud native. The first one, and I hear this a lot from large enterprises, is that managing legacy infrastructure is getting very complex for them. And even things like virtualization that have done a lot of good things in the last several years, it's still too complex to manage virtualized environments. They also mentioned that, and I hear this a lot from other enterprise customers as well, that they have a very long deployment process because they still have to go in and manually configure something or figure out what type of requirements they have around a compute, even if it's a VM, self-service environment. They have to go off and kind of figure this out themselves because they're getting cross-charged if they're using more than they need to use. And so they're trying to get smarter about how they use resources. And it's just very complex and takes way too long for them to kind of get to the right mix of CPU, memory, and network permutations that they want to support to be able to get something deployed. And so what we worked with them on was how do we kind of get better resource utilization and allocation for them, and also how do we kind of give them much more efficient orchestration. And in terms of deploying their services, their number one concern is availability and assurance, right? So they want to make sure that as they deploy these services if you ever used Webex and it didn't work, you were very frustrated, right? And so we don't want to have that experience, right? If it's not, maybe it might be caused by something other than Cisco, which is a different issue, but if it's a service disruption because we had a service process fail, we had something go down, that's not acceptable, right? And so they want to make sure that those services that they spin up will always be available. And so what this looked like from a requirement standpoint was they wanted to have global service discovery. They wanted to have, more of a global load balancing and they had some deep integration into the way the load balancing needed to provide certain types of elastic capabilities when they had certain, connections per second. Once they got to a certain level, they had to be able to make different changes within the load balancer. And so they want to be able to support a lot more complex sort of networking, if you will, at the edge. They required RBAC capabilities and more security capabilities within the deployments, right? So just C groups and just deploying services was not enough, and they wanted to have some kind of role-based controls. And then in addition to that, they needed to be able to provide our tenants, so our customers, with monitoring information, metrics about how things are performing on the Webex servers and components. Plus, they had to get logs for events so they would know if something was failing or something was delayed or if issues were happening. So they have this whole venting structure that they wanted to containerize and make sure they were loosely coupled components. But they always had to be a certain number of them available to collect a certain amount of data that they know they're going to get per second. And so there was a lot of requirements around how do we containerize these components but still ensure that we have a number of them available to support this level of connections. They also had some requirements on IP per container and doing things around service in a global manner. How do you manage service deployments and synchronize the data between these different deployments? And so a lot of our customers are global, and so they might have an office in New York and an office in Singapore, and they're trying to have a Webex. And the connection state of the voice and the video and some of the chatting that's happening on that Webex needs to be in sync. And so they wanted to look at some of these synchronization issues up front instead of waiting till after we deployed containers to figure out if this would work. And then they wanted to support a lot of the different components that make something cloud native. And so the architecture that we've deployed with them and are in testing phase right now with our Webex team is we've sort of created this global console interface, allows service discovery across multiple geolocations and a way to kind of define what the geo requirements are for those locations. And we put a sync agent inside each deployment of what we call Mantle, or this underlying set of services. They were only interested in Mesos, so we didn't deploy Kubernetes in this, but we let them know that as they evolve their development capabilities, to turn on Kubernetes is not difficult. It doesn't take a change request or anything hard to do, right? They just do almost like an app, a go get and install it, right? So it's pretty simple. And this kind of gave them, in the early testing we're doing, they're getting great performance. They're seeing the benefits of having kind of this isolated microservices architecture. And they're seeing some of the dependencies and failures that happen just in general when you have a global deployment of a network. They're seeing some of those issues getting resolved automatically, which is really exciting to them. And so with that, I know I'm up near the top of the hour. I want to at least leave a few minutes for questions if you guys had any questions about the Webex example or any of the work we're doing at Cisco.
Mr. Owens, what drove, what drove the specific requirement around IP per container for Webex?
So that's actually a good question. I'm glad you brought that up because it started out as an IP per container. And what they wanted to do with that was they felt like they needed in this world of the way the software is written and the way they like to connect and communicate between these different services, they were tying themselves to these IP addresses, which is a bad design, right? And so we worked with them, and we actually have now created VIPs for the different services. And so now they have one IP per service. And if that IP now can have multiple services behind it, and at the time they wanted to do one, it was difficult to convince them to do one per service. And now I actually have a couple of them that have 2 or 3 different services behind a VIP because they're so loosely, they don't depend on each other, but there's enough of a dependency there that you can kind of group them together and save in a lot of the routing overhead needed to support it by giving them a common VIP that they all sit behind. And the services communicate directly to each other anyway. And so it's not like you have to go across some routing interface to get to the next hop, right? So just putting them together just made a lot of sense. And then when you deployed them, it also gave them a smaller failure domain, which they were thinking about in general, but they didn't really understand failure domains like we do in networking, right? So they kind of had no idea that these things could cause all kinds of weird behaviors if you had a failure of this component that was located in a different data center than the component that was relying on it, because the timeouts don't come back very quickly, right? The network is good enough that it's always trying and retrying and retrying, and it takes like 3 or 4 tries before it basically says, I give up. And that was just taking way too much time and causing lots of weird behavior at the application tier because it was expecting this to just work. And it wasn't expecting a failure to come back, and it didn't know how to detect that failure. And so we've done a lot around this IP per container, and just in general, how do you kind of manage IP routing within this cloud native space with Webex? And it's a learning process, but I think they're starting to kind of get this idea of, I don't have to actually have an IP and a name on every single container that I spin up. Good question, thanks. Oh, well, thank you all very much for your time.